talk now about sequence problems. So many problems can be expressed as a sequence of items, either as input or as output. Let's look at an example we've already seen, would be, let's say, a Yelp review. Okay, so we have a sequence of words as our input, and as our output, we might have the polarity, positive or negative. So this is a sequence to a single output. So many to one. We can also have the converse, one to many. Here, maybe for instance, we have an image, and as output, we have some sort of a caption. So the image is some picture, an idyllic scene, and the caption that is output is, this is a pastoral image with sheep and a man sitting under a tree. Okay, so that is a sequence of output where we have a sequence of words. The one thing to note about sequences is many times we don't have a fixed length on that sequence. What are some other examples we might come up with? Let's say we have a input, which is audio samples. So this might be waveforms, or there might be some preliminary, so raw waveforms, or there could be some preliminary computation done on it, like let's say a fast Fourier transform. And as far as our output, so let's look. So audio as input. Output might be, let's say, who the speaker is. So we have a set of possible speakers. Or maybe what we're trying to do is come up with listening for a particular wake-up, like Alexa or Hey Google. So these are our audio samples as input, where here we've got time steps. So as output, what we really want to know is when do they say, let's say, Alexa. So let's say the word Alexa is right there. So our output can be a set of zeros and ones. That is basically for every time step, was there, Alexa said. And so it's maybe Alexa said in the last 50 time steps. The reason the last 50 time steps is we don't want to be so precise to say when they say Alexa, that it's right at that one single time step after they say We want some less precise, more general. So we could have maybe zeros here, and then as we get to the end, let's say about 50 ones, and then some more zeros. So for training, we'd basically say anywhere within the range, kind of after they say Alexa, that's all ones. So in this case, we have input, which is audio, and we have output, which is a sequence of yes, no, Alexa. The review to polarity is many to one. The image to caption is a one to many. The audio to speaker is many to one. That is in terms of a sequence, right? Many inputs. The audio to sequence of yes, no's is a many to many. And in particular, it's a case where the output sequence is tightly coupled to the input sequence. It's exactly the same length. So for every input, we have a corresponding output. We can also have sequences, many to many, where the input size and the output size are separate. And a good example of this would be language translation. So we have a sentence in English going to a sentence in, let's say, Spanish. Right, so here the input might be, my name is Neil. So 4 words, and the output, me llamo. So the output is not necessarily these 4 words. In this case, it's 3 words. Let's say we've trained a model on Hemingway. Let's say we've trained a model on Hemingway, and now we want to generate faux Hemingway. Okay, so what we might do is provide a prompt like, last night the wind was fierce. And then what we want is to get the next sentence or paragraphs to try and come up with a story in Hemingway style. So here we might have like a story prompt, and the output might be a remainder of the story. So this is dealing with sequences. Things to keep in mind. Often we don't know how long the sequence is going to be or even what its maximum size might be. Second, the sequences may be the input, the sequences may be the output, or sequences may be both. We could even, if we wanted, look at an image as a sequence. Problem is, when we talk about sequences, we really are talking about linear sequences. And so we could view this picture as a sequence of pixels going along the first row, the second row, the third row, the fourth row, and so on. The problem with that is that that then loses the spatial information that the first pixel in the first row is right next to the first pixel in the second row. So it's unlikely that that would work very well to use the sequence to input to our model a two-dimensional picture as a one-dimensional sequence. But theoretically, it could be done.